Hi, this is the Liceo Math Club. How are you doing this summer? Hopefully you're doing great and staying at home to enjoy these videos that we will be presenting. This is Sir A, the Liceo Math Club's moderator, and today I will be presenting logic and the basic topic, which is proposition. Anyways, logic is part of general mathematics, which is usually at the last part of the unit. Okay, so as an introduction, this batch of video lessons focuses on general forms of logical reasoning applicable to real-life arguments. This will provide you concepts, principles, and methods to obtain good and reliable arguments, especially when you reach the topics of fallacies, proofs, and the more advanced logic topics. This is where you'll really get into arguments. Okay, but we need to start with the backbone of logic, that is propositions. We have already made a general mathematics playlist, and in that playlist it contains a lot of logic lessons. Only that in those lessons it lacks the basic lesson. Actually, it starts with logical operations, logical connectives, but we forgot to put the proposition, so this is it to fill in the hole. Okay, so let's start with the question in mind. So let's try kind of ponder on this. Let's read statement number 1. Penguins are black and white. Okay, that's very clear. Penguins are indeed a combination of colors of black and white. Emperor penguins may have yellow on their heads or something. Statement number 2. Some old TV shows are black and white. Okay, so yeah, some old is not yet colored, so it's black and white. So therefore, based on these two statements, some penguins are old TV shows. Like, what? Nani? Okay, so we have, because the first statement says that penguins are black and white, and the second statement says some old TV shows are black and white. So they equated the black and white here. So if penguins are black and white and some old TV shows are black and white, therefore some penguins, their penguins are some old TV shows. So of course, that's a very wrong logical argument to say. These parts of syllogisms actually, it's just a little bit deeper lesson, but we'll come to that. Okay, so we need to show first the truth values of the statements and how is this a fallacy or not. Clearly it is, since penguins are not TV shows. But we're going to start with the basic parts of it. So let's start with definitions first. And we will be defining first what are we talking about. So we're talking about logic here. So what is logic? Logic is the study of principles and methods governing correct and reliable inference. So that's what logic is all about. It's kind of different when you talk about logic and philosophy. Logic in mathematics talks about the truthness of the statement. How can it be true? How can it be false? What are the patterns? What are the say the ways of getting to the correct conclusion to the sound argument? So that is what logic in mathematics is. Okay, so again, we're going to define propositions here, and we're going to tackle that. Propositions are declarative statements. Let me underline that. They are declarative statements, so let's take note of that, which are either true or false, but not both. Let's underline that. Again, either true or false, but not both. They are denoted by small letters. So usually in most textbooks, they use P, Q, R in most of the case. But of course, you could use any small letter there. Okay, so again, they are declarative statements which are either true or false, but never both. Moreover, propositions either affirm or deny something about a certain reality or object, but not both. Again, just like in the statement here, in the second what do you call that, second condition. So it's either true or false. So it's either affirm or denies something. Okay, so let's see some examples so that we could somehow say picture out propositions. So let's have this. Let's focus on the first line here. So we can see here, Bacolod is the capital of the Philippines. So it's denoted by P. So when you write symbols, when we write things in propositions, we don't usually write it in the whole worded part. We only write what is the variable here, the symbol. So the variable P, like in algebra, it serves as a variable that it means some statement. Okay, so P means Bacolod is the capital of the Philippines. So is this a proposition? True or false? Well, indeed it is a proposition. Okay, why? First, it's a declarative statement, so it declares something, it gives a statement. But is it true or false? Definitely, it's false because the capital of the Philippines is Manila, not Bacolod. So therefore, it's a proposition. First, it satisfies it is declarative. Second, it satisfies that it's either true or false. This is false, right? So this is indeed a proposition. Doesn't mean it's false. It's not a proposition. Okay, so it's either true or false. So it is a proposition. Letter Q. Q means 12 plus 9 equals 21. Okay, so 12 plus 9 equals 21. So it's a statement. It stands for Q. Is it declarative? Well, this is a mathematical sentence, and indeed it's declarative. It states that 12 plus 9 equals 21. Is it either true or false? Yes, it's true because 12 plus 9 is indeed 21. So therefore, this is a proposition. Okay, let's go to letter R rather. Mark Zuckerberg is the chief executive of Facebook. Okay, is this declarative? Well, yes, definitely. Is this either true or false? Yes, so it's a proposition. And this is true, actually. Mark Zuckerberg is indeed the chief executive officer of Facebook. That's the CEO of Facebook, the owner and the CEO of Facebook, the founder. That's Mark Zuckerberg. So that's a proposition. Let's go to proposition S. Are you one of my students in math class? Well, is this a proposition or not? It doesn't satisfy if you're going to look at it. This is not declarative. This is interrogative. It asks us a question. Therefore, statement number one or condition number one is not met. It's not a proposition. Rather, it's not declarative. Therefore, it's not a proposition. Period. Okay. Next, let's go to proposition letter T. Go, Karen. Well, it is not a declarative statement because it's imperative. It gives you a command, right? So go, Karen. That's not declarative. So therefore, it doesn't satisfy condition one. So it's not a proposition. Therefore, okay. Letter V. Keep your eyes open. Oh yeah, keep your eyes open. I am. But the question is this declarative? Well, really not. This is again imperative. Okay. Anyways, in T you could say that it is exclamatory. Okay, it has an exclamation mark, so it could be exclamatory. Okay, and here it's clearly imperative, so therefore it's not declarative. It's not a proposition. Okay, and then last for letter W, this statement is false. Okay, so is this declarative? Well, yeah, definitely it's declarative. Okay, but is it true or false? Okay, so to answer that question, let's try. Is this statement true? This statement is false. So if it is true, this tells us that this is false, right? Now, if this is false, this statement is false. So if we say that this statement is false, therefore it's saying that it is true because it's double negative. It's going to become positive, right? So if I say this is true, it becomes false. If this becomes false, this becomes true. Alright? So we can consider this statement as both true and false because it just rounded up, rounds true, false, true, false, true, false. So therefore, it is indeed a declarative statement, but it does not satisfy the second condition, which means that it should be either. Again, either, not both. Okay, either true or false. So this is not true or false, it's both. So this is not a proposition. This is one classic example of a paradox. Okay, wherein it goes on forever, doesn't have a true statement or rather a consistent statement. It runs around. Okay, so again, when you say that this is true, it's saying that it's false. If this is false, it's saying that it's true, and then again it round and round goes round and round and round. Okay, so those are examples of propositions. Okay, so let's define more terminologies here. So we have simple and compound propositions before we end. So let's start with simple proposition. Simple proposition, also known as atomic proposition, is a statement which only contains one functional part or idea. So simple as it is from the word itself, simple, there's only one idea, okay, one functional part. Well, it's also known as atomic. Well, we know as atoms as the most basic particles in matter, basic unit of matter in our universe. That's why it's called simple or atomic proposition. Next is compound propositions. So a compound proposition is a statement which contains two functional parts that are either related or unrelated and are being presented using logical connectives. So these logical connectives here, the bold and italicized words here, we're going to deal with that in the next lesson, in the next video. We just need to define what compound proposition is. So as you can see, it contains two functional parts, okay, and they are connected by logical connectives. They have two functional parts, two ideas, and such. So in analogy, we can think of simple propositions as, in English, as sentences. So simple propositions can be like simple sentences, and when you combine two simple sentences, we'll have a compound proposition or a simple compound sentence. So a compound proposition is like a combination of two simple propositions glued together by logical connectives. Like in sentences, they are glued together by connectives, or by conjunctions rather. Okay, so let's have some examples so that we could further illustrate simple versus compound propositions. So for number one, okay, some houses are made of wood. Okay, let's ask a question. Does this have one or more functional parts? An idea somehow. Okay, so some houses are made of wood. Okay, that's a single idea because some houses are made of wood. That's a single statement. So that's a simple proposition. Okay, not compound, only simple. Number two, all women are capable of giving birth. Okay, so let's think about it. Does this have more than one functional idea or only one? All women are capable of giving birth. So that's only one. Okay, a simple proposition then. Number three, if a rectangle has four sides, then that rectangle is a quadrilateral. Let's try to think of it for a bit. Does it have only one functional part or two functional parts? Okay, a rectangle has four sides. It is a quadrilateral. Here it is. So it is a quadrilateral. It's different from rectangles has four sides. So this has more than one functional idea. So therefore, this is a compound proposition. This is an example of a compound proposition. Okay, actually, we have some keywords to be thought of here. We have the if and the then. So those words are actually one of those logical connectives that I talked about in the last slide. We're going to talk about them in detail next video. Okay, let's go to number four. Either a person will eat pizza or a burger meal. Let's think about it. A person will eat pizza, or that person will eat a burger meal. So it has two functional ideas. Either he or she will eat pizza or a burger meal. So therefore, that's a compound proposition. Okay, because it has two functional parts or ideas. And number five, Maria is a laborer if and only if she works in a factory. Okay, as you can see clearly here that we have two statements. Maria is a laborer and she works in a factory, or we can say Maria works in a factory. So that's the compound proposition. Okay, so in number four and number five, we can see similarly in number three, if then, that's one logical connective actually. Number four, they use the word or. That's also one logical connective. And number five, they use the phrase if and only if. That's also one logical connective. And we're going to deal with that in the next lesson. Okay, so that ends our topic in propositions under logic. The next series of videos about logic will be given by our education committee of our Liceo Math Club, education committee of the school year 2019-2020. That was spearheaded by Shiltel Hamolas, our education committee, what they call it, chairperson. Okay, so it's really big thanks to her that this project was brought to life. So don't forget to like and follow our Facebook page. That's as simple as facebook.com/LCMathClub, no spaces, small caps all. And also, the video that you're watching now, like this video please, and put some comments if you want. Subscribe to our YouTube channel, don't forget that. And it's the YouTube link, or rather the channel that you can click subscribe is, I think, down here a bit.
I cannot move the mouse beyond the screen. Okay, so again, this is Sir A, Liceo Math Club's moderator. Thank you for watching this video of ours, and we are doing this project and so that we could be productive while we're staying at home. So keep safe. Thank you so much.